Welcome back for another example of difference quotients. So now we're looking at 1 over the square root of x, a combination of functions. All right, so if we look at f of x plus h minus f of x all over h, again, we can have that 1 over h out front, times, in the brackets, let's see, we have 1 over the root of x plus h minus 1 over the root of x. Let's get a common denominator like we did before. So we have this 1 over h out front times first fraction, multiply top and bottom by root x. Second fraction, multiply top and bottom by the root of x plus h. And this is all over the root of x times the root of x plus h. Now, let's multiply top and bottom. Again, we have something that looks like a minus b. This make it look like a squared minus b squared. So we multiply top and bottom by the conjugate of the numerator. So we have root x plus the root of x plus h all over root x plus the root of x plus h. All right, let's wrap that down. So what are we going to have here? In the top, we have our a squared minus b squared. So x minus x plus h all over. Denominator is pretty big. We have an h. We have a root x. We have a root of x plus h. And then in brackets, we have a root of x plus the root of x plus h. In the numerator, these x's cancel, and we remember to watch out for that negative in front of the bracket. So we get a negative h over, copy paste, h root x plus h, bracket, root x plus the root of x plus h. And now these h's reduce out nicely, and we're left with a negative 1 in the numerator. So we have negative 1 all over. We have a root x times the root of x plus h times, then in brackets, we'll have root x plus the root of x plus h. All right, that's the difference quotient using the x plus h. Let's do the alternative form now. So this is f of x minus f of a all over x minus a. Okay, so I'm going to put that 1 over x minus a out front. Here we'll have a 1 over root x minus 1 over root a. Now you'll notice a lot of these difference quotients, there's a lot of similarities, just how the notation was started changes things along the way, but it's roughly the same idea. Common denominator again. So the first fraction, we'd have to multiply top and bottom by root a. Second one, multiply top and bottom by root x. This is all over. Now we should have a root x times a root a down there times that x minus a. Multiply by the conjugate again. So multiply top and bottom by root a plus root x. And whatever we do to the top, we do to the bottom. To maintain equivalency, the top becomes a squared minus b squared, so a minus x. That's all over. Then we have root x, root a times x minus a, times root a plus root x. And now we factor a negative out of the numerator. So we have the negative of x minus a. Copy paste that denominator. So root x, root a times x minus a times root a plus root x. Now we see that these x minus a's reduce out nicely. And we have a negative 1 over what's ever left, right? So we have root x, root a, in brackets, root a plus root x. And there we go. Let's get set up for the next one.